I wish I could tell you more about that, but I have a very important story to share with you right now. We're going back in time. It's 1996, and I am 8 years old. I just got home from my Little League photo shoot, have grass stains in my pants, hopping out of the Astrovan and heading inside. And I don't know it yet, but I'm about to get my first exposure to programming that's going to change the course of my life forever. And it's all thanks to this piece of hardware. Now, if you are not an aching, groaning millennial like myself and not sure what this is, it's a Game Shark Pro for the Nintendo 64. And it's a physical piece of hardware that sat in between the video game cartridge and the video game console and allowed you to read, intercept, and override the values that were being communicated between the two, kind of allowing you to access the underlying primitives of the game. And here's kind of how it worked. When those values are being communicated back and forth, we had the ability to kind of latch on and overwrite that value with our own. So in the example of like Mario, typically Mario would run into a bad actor, the enemy in the game, and would take a little bit of a health hit. But with the Game Shark Pro, you could say, no way, Mario's not getting injured here, and always force that value for his health to stay at 100%. This Game Shark Pro allowed you to kind of bend the rules of the video games. But this wasn't really the only way to bend rules in a game. Sometimes the game's designers bent the rules as part of the game itself. As an example here, from one of my favorite arcade games of all time was NBA Jam. Again, another 90s release here. And this fellow with the lovely locks, his name was Mark Turmel. He's the lead designer and developer on the game. And Mark left his little impression on NBA Jam that he actually never even told anybody about until it came out later on. That hair, though. You see, Mark was from Detroit, so he's a big Pistons fan, the Detroit basketball team, and their rivals were the Chicago Bulls. And so what he wanted to do was make sure that his team was always going to beat his rivals. So without approval, he kind of went rogue. He programmed the game so if it was a close game between the Detroit Pistons and the Chicago Bulls would suddenly just start throwing bricks at the last second and would never really win. They would never beat the Pistons here. Um, and he didn't tell anybody. He just left his mark on the game. No pun intended there. It was these kind of video game cheats that were the first time that I started to understand that the rules of the world around us are just rules. Somebody out there made them up, which is like great news because that means that we can bend them. We can change them more into what we're dreaming up and not what the factory dreams up for us. In fact, I would go so far to say as that we should bend the rules. As web developers, we're often asked to implement projects to spec, but that doesn't mean that we shouldn't have a little bit of fun too, right? I mean, we're human. We don't have to be reduced to a Jira board and a daily stand up. So it's our responsibility, I think, to fight back against the man, to take a stand against hierarchy and process, to challenge cultural and workplace norms, to work less, play more, to defend our calendar, and to keep the wild and weird World Wide Web alive in our creations. Um, I'm going to take this really quick. And just for the effect, let's pretend we're all in the same physical room together where this talk is normally given. Steve.
Hey, Dave.
eh,
Whoa, look at that background. Is that so realistic? Where'd you get that conference background?
it's not a background, Steve. I'm in the middle of a talk at Pixelpalooza right now.
Wow. Okay. Hey, everybody. So you're busy?
I guess not. What's up?
Okay, well, quick ask. I just need you to put together a example of a video player using MediaChrome, our player toolkit. Just something fun, be creative, don't be afraid to get inspired, really hoping to show off what we can do with it.
Okay, I can do that.
Just be sure to run it by me, the team, before you show it to other people. Okay, but have fun with it.
Yeah. All right, I'll run it by you.
Cool. And while you have everybody there, don't forget to tell them about our plans for video jazz.
Yeah, that's actually a pretty good idea. I will. I'll let them know.
Cool. All right. Thanks, Dave.
All right, see ya. It's always just a quick ask, isn't it? Run it by the team. At least he is kind of right here. I mean, Mediachrome's a really neat library to be playing with. It's kind of the video and audio player toolkit that we have available to us right now that we've built over at Mux. It is based off of web components. It can work basically with any web architecture and gives you the ability to kind of explode the video player that you're used to using into separate components that they can all be placed, styled, and interacted with in whatever way you can dream up. With Mediachrome, similar to with GameShark, you can access those underlying primitives of the player and change it into what you can dream up and not what somebody else dreams up for you. I wonder what we could dream up here. I want to be able to bend the rules. You know, what could I dream of? I dream of a player that could help me fight the good fight. Help me actually play. None of this business stuff all the time. Hmm.
Yeah, quick ask here. Run it by the team, show it to the team before you show it to anybody else. So something fun, be creative, be creative.
It's a me, Mario.
Directional Pro redefines the rules, letting you set the agenda.
That's it. We can set the agenda. We can build a player that plays. Why don't we build a video player like the games in the arcades of my youth, where you don't just play the video, you play the video. These 3D engines on the web have come such a long way. We could totally do this. Steve's going to love it. I think what we can do here today is walk through how we can build a 3D coin mechanism in Three.js that can then connect to Mediachrome to control video playback. And at the end, I'll show you what I think the future of video players on the internet looks like with Video.js. How's that sound? Well, I can't hear you at all. So I'm just going to assume that you're cheering and screaming my name. So I'm just going to keep moving on forward here. Let's go ahead and start building this 3D scene where we have a 3D coin mechanism that controls a video player. For this, we're going to use Three.js and a wrapper React library for Three.js called react-three-rapier. If you're familiar with React, maybe you've never written any React before, and that's totally okay. But what we're doing here is assembling kind of a tree or a 3D scene. And inside of what we're going to call a canvas here, using the canvas component, we're going to place different elements, different geometries, and different things that kind of come together and build out this 3D scene. So here is the code that we are using to just initiate this 3D scene, right? We're importing a canvas from the react-three-rapier library. And I'm also importing a perspective camera and camera controls from a utility library called react-three-dry, which is German for three, if you didn't know. Today I learned, well, yesterday, I guess, but Canvas, we have it here as sort of the base component. We are inserting a child perspective camera and camera control. So let's go ahead and just render this out. And we don't see anything. Well, we haven't added anything to the scene yet, so we need to go ahead and start laying some groundwork here. So I'm going to add another component to our scene. These components are these chunks, these building blocks that we're using to build the scene out, remember. So here we have a ground component that we're writing, and what we're introducing for the ground is a mesh. Now, a mesh is sort of just a collection of geometries and materials that are held together sort of in this container. That groups them together. So we have this mesh that we're saying, let's make sure it can receive shadows. I'm going to want shadows to appear on the mesh at some point. We're going to rotate it so it's not standing up. It's sort of laying on the flat side there on the ground, or representing a ground, and just using a plane geometry, which is just a flat, big old box basically. And I'm going to apply a mesh basic material, which is just kind of a gray material here. So let's go ahead and run this. And look, now we have our ground, which we can sort of, since we have the camera in place, we have the ground, we can interact with it and see our scene is coming together. It's not much yet, but let's, Rome wasn't built in a day. Let's apply some carpet. The carpet from my youth, when I remember from the arcades that I went to, was sort of this stained, wild patterns, very neon colors, which I learned later that was designed specifically, I think, to hide popcorn. That was kind of interesting. I don't know if that's true. Don't Google it. But how do we apply that sort of pattern to this plane geometry? Well, we're going to use a specific loader from React-3 Fiber. We're using this use loader or the texture loader. I think it comes actually from the underlying Three.js library, which we're using here. But use loader, basically what this is doing is allowing us to use React suspense for easy loading and error states. There's all kinds of loaders that you can use with Three.js. There's animation loaders and audio loaders and image loaders. Here we're going to use a texture loader. And this texture loader is going to basically take an image and pop it into this texture map that we can then apply right onto the material down here. So take a look here. We are importing the texture loader. We are setting it so that it repeats on its axis that we need it to here. And we are going to apply it right here. We're going to change this mesh standard material or from a basic material to a standard material, right? Apply the map, the texture map here. I'm passing it, setting it up here with the loader, and I'm passing it down here and just making a couple changes there to the way that map is going to appear, the roughness, the metalness, kind of change the properties of what happens when light interacts with this particular mesh. So let's go ahead and apply this. And oh no, it looks like we broke the scene. Don't worry, we did not break the scene. We just don't have any lights in this scene at all yet. So of course we're not seeing anything. It's like you walked into a room with no lights on. It's pitch black. We need to do that now. When we change from a basic material to a standard material, the basic material is emissive, meaning it gives off some of its own light and sort of glows in a way. This material is not emissive, so it needs its own light to be visible. So we're going to use what's called an environment here to provide some light to the scene. So I'm going to import an environment from React-3 Dry. And an environment is basically kind of like, have you ever seen the Truman Show, the movie, where he's kind of walking around in this big like fake world and you can see the sky and the wall is like kind of fake. That's kind of what's going on with an environment here too. It's this global cube map where we are surrounded on all sides with sort of an image, really. And the image can be visible or it can be invisible. But either way, the lighting data, the brightness data from that image is going to be used to bounce light into the scene and help to kind of globally illuminate the objects that are in that scene. So here I'm importing an environment. We have our ground component already, and I'm just adding the environment with a preset of city to the scene. This preset is just a picture of a city. That's all it's doing. So it's going to use the lighting information from a city and apply it to our scene. And if we go ahead and apply this, we should see, there we go. There's our carpet. That's what I was envisioning this whole time. So that's starting to look a little more funky, like an arcade carpet. And I feel pretty comfortable moving forward now. All right, so I said what we're building here is going to be a coin mechanism that controls a video player, right? So we need to have the box for the coin mechanism. Let's think inside the box here and figure out how to add this basic box to a scene. Now we've learned about a geometry, which is just kind of our shape, right? We can also, we have a plane geometry, which we use for the floor. We can also have a box geometry in place, and that box geometry will allow us to define sort of the size and position of where this box should be appearing within the scene. So I'm not doing anything really too different here than what we did with the floor. I have a mesh. I'm telling it that it should be able to receive shadows and cast shadows. I have a physical material, which just allows you to dig in a little further and what that lighting impact is on the geometry that it's applied to, or the mesh that it's applied to. And this is just kind of the sizing and positioning data for where that box needs to appear within the scene. So nothing really terribly different here that's happening. Let's go ahead and apply this to the scene. And there's our box. What I don't have here, or here it is down at the bottom here, is this red faceplate. So there's another mesh that I carefully positioned just in front of that kind of gray box that is a little smaller and still kind of maintains this square shape here. But you can see that the color here is red, so that's changing the red property. And this is just very carefully positioned. So it's just a box that's sitting on top of another box. I don't know why I'm talking so much because that's all it really is. So let's go on to the next part of this scene. It's not much of a coin mechanism if it can't accept coins, and a box, you can't just put coins into a solid box. We need to be able to cut into this solid box and create a coin slot. So let's go ahead and do that here. We're going to use another library. This is Library City for this talk here. This one is a poorly named library called Three.js, which of course stands for Bounding Volume Hierarchy Constructive Solid Geometry. It's kind of a fancy way of saying cut holes and stuff, as far as I understand, but do it kind of fast. But basically allows you to add, subtract, and mask shapes together in real time. So we're importing 3 different helpers here. This is the operation that we're going to perform. It's a subtraction operation, kind of a Boolean operation. We have the brush. This is going to kind of create the 2 areas that need to interact with one another. And the evaluator is kind of, I don't know, I picture it like the saw that is making the actual cut here. So let's see what's happening. So we have the main box brush in place here. So we're kind of just tracing this geometry, the same size here of that geometry that we defined before. The same goes for this slot hole here. We're kind of very carefully resizing, squishing it down, and positioning it right here on the side. You can kind of see this getting cut into place. And until we run the evaluator, nothing happens until you run the evaluator. So here we're kind of saying subtract the slot hole from the main box. We have the result, and then we're updating. We had a handle to that original box using this ref here. We are saying, hey, replace the geometry from that original box with the result from our evaluation here on this Boolean operation. So that's basically just a long way of saying, again, we're just cutting holes and stuff. It's kind of like what I did with 2 weeks left of shop class back in high school. Just drilling holes. Bonus points if you remember that reference. But we got a hole here. Now I could drag around and kind of show you that this is like an interactive, you see right through it. You see the carpet in the back there. It is working as expected. So let's keep on rolling here. There's also these really great utilities within React 3 Dry to put text right into your scene, which is pretty cool too. Very easy, nothing really too wild looking here. We position the text, we give it a size, we give it a color, and let's apply it to the scene. That easy to apply text to a 3D scene, and you can just change out this text right in your React tree to be able to modify it if you wanted to do so. So now the text, again, is carefully positioned right on top of that red faceplate. So let's keep rolling here and see what is the next step. This is coming together. We can kind of see the vision here, but it is still looking like it was vibe coded or something like, you know, it's not very impressive. So we need to apply some materials and change the way that this geometry presents itself. How do we do that? Well, there's a couple of different approaches that I'm going to take here with this particular scene. One is going to be using a transmission material for that red faceplate. Whenever I remember one of those old arcade games, you used to be able to see kind of the glow of the lights kind of coming through and refracting throughout that red kind of plasticky faceplate. And then the coin mechanism sort of had this like, I don't know, like grippy, bumpy type of rubbery texture to it. I don't even know what that was. Probably not very safe, but we're going to try to mimic both of those here. So we have this transmission material, which comes from the React-3 Dry utility library. And we're also using a normal texture helper, which I'll get to here in a minute. But we're doing that first. Look, a minute is up. The normal texture. So what a normal is in the 3D space is basically an RGB image. So it's just a kind of a data image that tells light how it should respond to the material when the light hits the material. So rather than making, I told you that this coin mechanism, I remember being kind of like bumpy, like little tiny bumps on it. If we were to actually physically make this 3D box change the geometry to make it bumpy, it would be a very, very expensive operation to do. Calculating all the math to kind of carve out all of those little nooks and crannies on this 3D coin mechanism just wouldn't really do very well for what we're trying to go for here. So a normal texture, instead, that just fakes it. That just says, here is an RGB image of what looks to be how bumps would kind of respond to light when they interact with it. And based off of the value, if it's red or blue or green, it will sort of tell the light to do something different. And there's some different, this is a little bit simplified here, but there's some different strengths that will be applied here to kind of give the appearance that it's super bumpy, but it's not actually very bumpy at all. And then here at the bottom, we have the main coin box. That's the normal map. The transmission material we're applying to that red transparent faceplate. So we're using this transmission material with some specific properties here to say, let's keep it red, but we're going to allow it to the light to pass through it. A lot of this is kind of baked in straight in the transmission material, and you can just kind of tweak some of these parameters. I played with it a little bit to just get it looking like how I wanted it to look. But let's just see how this all came together after these were applied. Whoa, big difference there, right? I'll just drag around here and you can see if we're zoomed out, we won't be able to tell, but you can see that this box is entirely flat, even though if you look at it, it kind of looks bumpy or it's got like creases or ridges in it, right? But it's actually flat when you get closer to it. That's how these video games kind of have faked the appearance of a real texture, but not actually having the texture. And then look at this with the transmission materials. The text is now kind of refracting based off of the camera position. We got light bouncing off the top there. That's pretty convincing. It's looking a lot better than it was. Let's just do some really neat little cinematic camera movements here. Ooh, sweet. I like how that text is moving. It looks a lot more convincing, but it's still a little dark for me. We need to make it more enticing to insert a coin into this slot. So we need to start adding some more lights to this scene. So we have this sort of environmental light that wraps the scene, right? It's invisible, you can't see it, but it's projecting into the scene. We can also add specific kinds of lights to the 3D scene as well. There's point lights and spotlights and ambient lights, all kinds. Here we're gonna use a directional light. And I'm picking it up off the ground, putting way up high in the sky, like it's kind of like a sunlight here, setting the intensity, telling it, cast a shadow with the objects that you're running into, and let's see what happens when we apply that to the scene too. Whoa, there we go. Okay, much better. So you can see this yellow outline is the light itself, and that this cast here is kind of showing you where that light is pointed. So that really made a big difference here. Let's just zoom in and take a look at the before and the after. So here's what it looks like now. Look at there. There's the before. It was really dark and kind of hard. Everything's getting kind of muddy there. And the after, much better. But still, we want to make it enticing to insert these coins into the coin mechanism as well, right? So we could add little point lights into there as well. These are just the little points that I marked as red and position them very carefully. So it's kind of drawing you in and wants you to insert some coins into this thing. So take a look at how that's interacting with the red faceplate. There's also, you can kind of see the city buildings here if you look close enough in that red faceplate. That's from the environment that's coming around here. But that's making a big difference, these little point lights. One more cinematic movement so you can see how that's all interacting with one another. Very cool. Truthfully, I have no idea how these lights are getting any energy, any electricity. There's no wire on this thing. There's no battery installed. We need to put a wire on this coin mechanism. So let's go ahead and do that here. It's just another mesh. We're learning here, maybe you're sensing here, that everything in 3D is kind of faked. We just are creating very specifically positioned and reflective materials and geometries to make things look more realistic or more appealing. So here we have a cylinder geometry that I'm going to kind of put right where I need it to go, along with a standard material, which has sort of its own emissiveness. We talked about that briefly, where, I don't know, electricity is kind of magic to me. I know that there are explanations for this, but how does it work? I don't know. It's kind of magic. So let's make the wire kind of glow a little bit like it's giving off its own magic. So let's go ahead and add this wire to the scene as well. There we go. Cool. So that's coming together. And you can see, we go under the floor there. You can see how that looks like it's plugged into the back there. Starting to feel like a real deal, right? Okay, let's go around this way. Now, one thing that I do need to do is add a Mux logo to this coin mechanism. After all, this is my employer, and I don't think that, well, this is how I get my coins in my pocket, so I always have to give them a shout out when I give this talk. Mux is going to be powering the video later on in this talk for how this video player is controlled, but always a shout out to Mux for helping out with these talks. But let's get back to the coins itself. The coins are really what's going to be powering this video player, right? So what do we do? What do we do with the coins here? Well, we're using techniques we already know about. We're using a loader to apply a certain texture to them. We're going to use a cylinder geometry and just kind of squish it down into like a pancake type cylinder. Very, very, not very tall at all. And we have the standard material. And then I'm going to position it so it's way up in the sky because I'm envisioning these coins kind of dropping out of the sky into this scene onto the floor. Then we can start to pick them up and interact with them. So let's go ahead and do that. Well, it's added to the scene, but it is not falling like I thought it would. Why is that? Well, while we were able to position this geometry up in the sky, physics are not by default included in 3D. 3D is all sort of, like I said, precisely positioned and lit materials that will just kind of fake it that things are working the way that they would in the real world, right? If we want physics to exist, we need to introduce that into the scene as well. So if I'm picturing that these coins are going to drop to the floor, then we need to do something about that here. So we're going to use another library. We're using react-three-rapier. This is introducing rapier physics, which is just a kind of a fast WebAssembly powered physics engine. It's really great for performance in the browser versus some other alternatives that I was exploring. And this kind of handles all of the interactions, the gravity, when the coins are going to be shooting through this coin mechanism, it'll handle the collisions and so on. So we'll go through how we're going to use this entirely throughout the scene. But we are applying two different elements. There's this rigid body and there's this collider. And they have two kind of different purposes. The rigid body itself is telling the physics environment that there is something here. At this geometry, we're sort of like very carefully positioning this rigid body and this collider right over the coin. So it's almost like a coat that it's wearing, right? To say there's a physical item within this little container here. We can specify what that position is right on the rigid body. We can also assign this is metadata, really. Let's call it what it is. What's a type of this thing? So we can then programmatically look up when a collision happens, what just ran into me? We can refer to that value here. It'll kind of keep that data along for the ride as the scene's rendered. And then we don't want it to render its own colliders. We're going to give it that's particularly specific collider that's very precariously placed right around that coin itself. So these are some additional parameters here that just say, how is this coin going to interact with the scene? Is it bouncy? Is it going to drag if it hits the floor? You can kind of play with these values and see what are the right values for a particular scene. But here were some fun ones that I came up with. And let's apply this to the scene and see. Okay, well, it fell into the scene. I don't know where it went. What happened there? Well, we told the whole scene about the coin having physics, right? But we did not tell the scene about the floor having physics. So we need to add a same deal here, rigid body, to the floor. So I will go ahead and do that. I don't know if this comes through very well, but now we can see this debug sort of XYZ axis here, these lines. That's just kind of representing, yes, this thing has now applied physics, a body, rigid body to the floor here. So if we were to run that again, we should be able to see a little bit more of what we would expect. We can add those colliders similarly to this coin mechanism too. So what I'm envisioning happening here is if a coin is going to land on top of this coin mechanism, it should not pass through like a ghost, this coin mechanism, which is what it would do. It's just what happened with the floor. So we need to add a collider to the top, to the sides of this coin mechanism, to the bottom here. You can see I'm just kind of carefully positioning these kind of walls, but I'm leaving a gap here right in the center to allow for coins to pass through. We have this visual slot, which doesn't actually do anything. But then as soon as we create these collider slot, that's where the coins can actually pass through. So if the coin were to hit over here, it's not gonna work. It's gonna bounce right off of it. But if you get it right in the middle there, it will go ahead and pass through this coin mechanism now. So let's add some coins to this scene. We're gonna need more than that. There we go. I think we're gonna need more than that too. There we go. Now it's starting to feel pretty good. Okay, so it's looking like it's almost there, almost like it's about to be fun, but we can't actually interact with these coins in any way right now. They are having their own interactions with the physics in this scene, but there's nothing. If I were to try to drag around on that coin, it's not going to do anything. It doesn't know anything about me at all. So we need to change that using another library here. It's going to be called use gesture react. Gives you this drag helper here. So I tend to get a little wordy on this code block here. I'm going to make this kind of simple. It's essentially what it's doing is detecting if what this drag handler is applied to, the thing that it's applied to, which is the coin, if it detects that I'm holding down on my mouse or with my device on my pointer, then it should pick this thing up. It should override the physics that exist within the scene. And that's what's saying here. Where is it? Is its body type? Yeah, there we go. The body type here, I'm changing it from saying here, number 2, this is kinematic, meaning I want to control the physics. Don't let this scene take over here and apply gravity. There are no more rules. I am in control when I am saying that it is grabbed and I have the correct coin grabbed. And then when I let go of this coin, I want to return back into the physics of the scene. So I'm going back to a body type of 0, which is the dynamic physics. And then I'm also applying a small impulse on the z-axis here, very small, that just kind of pushes the coin forward. Boop, just like I give it a little flick, basically. And this, if I didn't do this, the coin would just fall down when I let go, right? Because it's back in the scene, but it has there's no force behind it in any way. This is applying that force, just a little touch that'll push it forward and allow it to go through into the coin slot. Let's continue on here. So I'll apply that drag handler, and now we can see that we have the ability to pick up a coin, get it into one of those coin slots, which is nice. Sweet. So we're on the right track here. Nothing happens right now when you put these coins into this coin slot. We need to change that now. So let's go ahead and add a sensor. The sensor is essentially this little collider that's very similar to the colliders that we just set up, but the collider is set backwards into the scene and allows the coin to detect when it intersects with this collider, fire a callback event, and allow that callback event to then control something else. That's all it's doing. I'm placing the collider into the scene back here. You can kind of see it, this yellow box. And when the coins will interact with this collider, we'll play a sound, we'll flicker the lights in the scene, and then we'll fire off a callback event to just say, an intersection entered, so let's handle that coin inserted. We'll call this function, make sure to debounce it so it doesn't get fired more times than it needs to. All right, so I've done all of this so far, and we've done almost nothing about a video player. Steve's not going to be very happy about that, so let's go ahead and change that. Here, we're using Media Chrome to apply a video player to the scene. I mentioned before, you can kind of blow up the video player into multiple components, right? So that we have a control bar and a volume slider and a mute button, and we can show those conditionally based off of whatever we dream up. So here, I'm only going to show the controls for a volume if the video is playing. And what's going to control the video playing? Well, if you insert a coin and it intersects with that collider that we positioned back in the scene, then it will add 3 seconds of time to your timer and give you 3 seconds of playback. When that timer runs out, then you need to insert another coin to continue to play the video. So that's what's happening here. We can kind of conditionally control all the different elements of this video player because of the way that Mediachrome explodes all of the different elements into components. So we're just doing some kind of nifty conditional controls here. And again, streaming the video from Mux that will make it really easy to play this video back into our scene. So let's go ahead and get this thing going so Steve's not getting mad. All right, it's looking like it's ready to play back here. So if y'all don't mind, I'm just going to go ahead and start to let this thing rip. Let's grab a coin and just start to play this game.
Final round.
It's also kind of fun to just huck these coins into outer space. Oh, you just throw a Zoom notification at me? Yes, let's go. We're almost there. Continue. Oh gosh, I need one more coin. Here we go. Oh no. Oh no. Yes. All right. We were able to win the game and beat the man this time. I got pretty lucky. Hopefully I didn't mess up the display too bad. I think I accidentally clicked something in my browser. So we kind of almost ran out of coins here. If I were to continue hucking them in outer space, what would we do? Have no fear, because remember, rules are just rules. And you can make up your own rules. So here, I'm applying another rule that says if you were to wiggle that wire enough, it will just add more coins to the scene that we can then interact with. So we're accumulating how much movement is happening on this wire. And if we kind of pass a threshold, then let's go ahead and call a callback here on wire wiggle, and we'll reset the movement counter. So we can kind of see that in action here. Let me just grab this wire in the back. Just give a little wiggle here. Sweet. We're back in business. All right, so this is the most amazing player I've ever built. Steve's going to love this. Let me just send it to him really quickly here. Oh, Steve, one moment. Compose. Steve, here's the player you requested. Let me know what you think. Give you the project here. Worst player style. Looking forward to your thoughts. Send that puppy off. Sweet. All right, so again, just a quick review of the stack we covered here today. We have the react-three fiber library, which was controlling Three.js within React, react-three-rapier for the physics in our 3D scene, use gesture React for the drag handlers with the coins and the wire, and then react-three-dry for so many utility helpers that we used, including the cameras and some materials and so on. And a lot of this is coming from the same group over on GitHub, which is a great follow. It's this Poimandri's group here. So I highly recommend checking them out if you're interested in this stuff at all. They're doing some phenomenal work. I'm unaffiliated. I just think they're really great. And then the video side, we're using Mediachrome for the video player itself, and then Mux Video to power the video playback here. So one more thing that I have to share with you. We did talk about Mediachrome a lot today, but we're breathing new life into a player that has been around for a really long time, 15 plus years now, Video.js. We're taking some of the best parts of what we've learned from Mediachrome and bringing them now into Video.js, which is kind of a much broader visibility with that particular project. And we want to make sure that that project stays alive. So I think you should keep up to date with the future of Video.js, where we're performing this revitalization and making sure that it's applicable, again, to all of the different frameworks that are out there to make it just as composable as Mediachrome has been too. So that's happening right now. Q4 2025, we just released a technical preview. There's an alpha beta hopefully coming here in a few months. And then Q1 2026, this should be stable as well. So if there's one thing that I can leave you with today's talk, maybe it's to check out Video.js, maybe it's check out Mux, but really, I want you to consider bending the rules. I think creative libraries like these allow you to change kind of what it means to build on the internet. It's the flavor of creativity that I often feel is missing from the World Wide Web today. I just really hope that you would go ahead and do your part to also bend the rules. See how you can get creative on the web and continue pushing the boundaries of what you know and what you think that you're capable of. Because really, I mean, we're the ones that are making up the rules anyway. Um, I should probably get back to Steve here. So I'm going to wrap this up. But thank you for your attention and happy to answer any questions that come up.